Hi, my name is Vishesh Konduru, and I'm the captain of Era 404, Team 3735C. Our team started last year with Tipping Point. We all met for the first time in a Robotics 1 class where we were in a group for the in-class and school competition. Even though we started building our bot halfway through the year, we found out that the top teams in the class competition could compete in the TSA VEX competition. Although it was our first year, and we only had a few weeks before the class competition, we said, so what if we're a Robotics 1 team with only a few weeks left? We're going to make it to TSA. I had some experience from overseeing FTC, and so did one of our members, so we decided to CAD our robot instead of just blindly building, which made the building process for our team way easier as they could follow an exploded assembly like Lego instructions. The more we built, the more serious we got. We started meeting after school, before school, in our free periods. We decided to use the WPI block code due to its simplicity and our limited time. And when the day for our class competition came, we managed to build a bot and code it in time and got first in our school. So even though it was our first year, we ended up beating the Practicum and Robotics 2 teams at our school and went to TSA Regionals where we advanced to the TSA State competition. And that is the true start of our team. We learned a lot from TSA Regionals. After, we did a retrospect, evaluated our performance by rewatching our matches, and reevaluated our priorities to better redesign the robot. This time, we decided to give more importance to coding and driver practice. Instead of hard coding the auton like we did at Regionals, we decided to use sensors such as inertial and distance to make more consistent autons. We made it to the round of 16 past all line selection at TSA State, which is further than any other team from our school had ever made it before. We made many friends and even started our own alliance, Xeno Alliance, which currently has 8 teams. As the captain of our team, I have been involved in all aspects of the robot design, building, CAD, coding, engineering notebook, and outreach. We follow the engineering design process and the agile design process for our programming. At the beginning of the season, we analyze the game when it's released to find and prioritize the scoring objectives. Then we brainstorm multiple different mechanisms to achieve those objectives. And together, we make and design matrices for each mechanism to narrow it down to 1 or 2 per subsystem. Then we move on to prototyping to test the concept. If it moves on, then we CAD, build a final design, test it, and reiterate as needed. As captain, I lead these sessions and document each one to meeting notes. I also schedule our meetings and delegate tasks. Every week, we make a master timetable where we delegate tasks and the deadlines for those tasks. This year, all of our members are actually in different class periods, so we use that to our advantage. We delegate tasks in the order they need to be done, and in class period order. So if task A needs to be finished for task B to be done, we assign task A to a member in 5th period so that when they finish task A, our member in 6th period can do task B since task A is already done. VEX has really taught me how to organize all my different activities efficiently, manage my time, and most importantly, communication skills. My communication skills have really improved as a team captain, as I talk to the team, have to relay information between different subsystems, and do a lot of outreach and talk to other teams. This year in the 2023 spin-up season, we are participating in both TSA and VRC competitions, and have qualified for state in both of them. I spent countless hours working with my teammates to ensure that our robot is not only functional, but also innovative and efficient. Although we could not work on our robot during the summer, as team captain, I called online meetings with my team over the summer to design and CAD the robot so that we could start building as soon as we got back to school. This year, we decided to challenge ourselves with the holonomic, or X drive, instead of the traditional tank drive. This allowed us to add a lot of functionality to our robot that would have been hard for other drive systems. Having to share all our parts with 12 other teams across 5 robotics periods, we are limited on what we could use, so instead of using tracking wheels for odometry like many other teams, we wanted to find a simpler solution that would allow the same functionality and that any rookie team could easily adapt and use for their robot. We ended up using only an inertial sensor and a vision sensor. With the inertial sensor, we made our X-drive field-oriented, so no matter which way the robot is facing, forward on the controller moves the robot forward relative to the field. This gives a lot of maneuverability against defending bots and movements such as spinning while moving in a straight line. I also created functions in the code with simple parameters, like a goto function that moves the bot a certain distance over a certain time, and with an X drive, this lets us even move in the diagonal path. And the turn to function that turns the robot to a heading relative to the field. This helped a lot with coding our autonomous for 2v2 and programming skills, so the robot would go to and turn the same direction every time. And with the use of these functions, anyone could easily code an autonomous for their robot. With a vision sensor and a simple PI loop, our robot is able to auto-aim at the goals from anywhere on the field. It also takes the size of the goal, and depending on the size of the goal, automatically sets the flywheel speed. So, as a driver, I don't have to worry about lining up or setting the flywheel speed. At any place on the field, the robot can auto-aim and automatically sets the flywheel speed, so all I have to worry about is firing the discs. As team captain, I encourage my team members to share their ideas, opinions, and concerns, which has led to a more collaborative and cohesive team dynamic. Even though we spend hours working on the bot every day, going through hundreds of iterations, we find ways to make it fun and it never gets boring. We also sometimes venture into some fun side projects or concept proofs, such as the scissor-like lift expansion rather than string expansion, and try to make our own compressor from VEX legal parts that could be put on a bot. My involvement and contribution to our VEX products team have been significant. I've been committed to our team's success, and I've dedicated my time and energy to ensure that our robot is the best it can be, while also making sure our team members have fun. From simple class robotics students to the first team in our school to make it to playoffs at TSA State last year. And this year, we were the first team from our school to get first place in TSA Regionals, and the first team in our school, and the only team in our district this year that advanced to the VRC State competition where we made it to the round of 16s. I'm so proud of my team's accomplishments so far, and I'm excited to see what they can achieve in the future and what I can accomplish at WPI.